Thank you, Jerry, for that introduction. As Jerry mentioned, I am Nathan Coy, and I'm going to be talking about the nuclear renaissance, fact or fiction, continuing on. First, I'm going to talk about Watts Bar 2 construction. The construction and scheduled commissioning of the Watts Bar 2 nuclear power plant in Spring City, Tennessee will be the first commissioned nuclear power plant in the United States in over 30 years, since its counterpart, Watts Bar 1, in 1986. Watts Bar 2's managing and operating company, Tennessee Valley Authority, was granted authorization to begin construction in early 1973, but construction was put on hold in 1985. Watts Bar 1 also had a suspension in construction in 1985, but in 1989 resumed construction, as opposed to Watts Bar 2 that didn't recommence construction until 2012. The Tennessee Valley Authority, or TVA, decided to resume construction of Watts Bar 2 in 2007. They requested to resume construction in July of 2008, but due to industry restrictions and approval processes, it wasn't until 2012 that the Nuclear Regulatory Committee approved and the Tennessee Valley Authority Board of Directors approved construction to resume. Current construction of Watts Bar 2 makes it one of only 5 current nuclear power plants being built. The other 2 being 2 Vogtle plants in Waynesboro, Georgia, and 2 more at VC Summer Nuclear Station in Jenkinsville, South Carolina. The nuclear power plant in Spring City, Tennessee is an 1,150 megawatt Generation 2 pressurized water reactor and will be capable of supplying electrical power to approximately 600,000 homes. The continued construction of the site has taken nearly 3 years since construction resumed. The plant is currently on schedule to be completed in the fall of 2015. While construction is still ongoing, training of the future operators has also been in the works. It takes qualified operators to maintain continued supply of power to the power grid, and so 81 personnel began training in late 2010 to allow for successful and safe operation of Watts Bar 2 during startup and critical operations. Of these 81 students, some will become auxiliary operators, while others will become reactor operators, or ROs, and senior operators, or SROs. These students, some internal and others external to the Tennessee Valley Authority, take part in nearly 2 years of training and are required to take and pass numerous safety and comprehensive examinations prior to ultimate qualification. So that's one of the 5 different power plants that are currently in construction. Now let's talk about some new designs to different nuclear power reactors that are in the works. Since the early stages of nuclear power, pressurized water reactors have been in existence. Between the 99 operational nuclear power plants in the United States alone, 65 are pressurized water reactors, or PWRs, and the other 34 are boiling water reactors, or BWRs. These 99 operational power plants, per the Nuclear Regulatory Committee, or NRC, account for approximately 20% of the electrical generation made available for our use on a daily basis. This includes all sources of commercially available energy: hydro, coal, gas turbine, cogeneration, solar, and wind. These examples of power generation are getting an upgrade to the APWR, or Advanced Pressurized Water Reactor. One version in particular, shown on the PowerPoint as you see it now, the U.S. Advanced Pressurized Water Reactor, designed specifically for use within the United States. This version of the U.S. APWR is designed to achieve superior safety, reliability, economy, and compatibility with the environment. The new design of this nuclear power plant should receive a more welcoming ovation from the general public due to the new engineering design changes. Many in the general populace are concerned about the efficiency and safety of nuclear power plants. The new U.S. APWR achieves an astounding 39% thermal efficiency as compared to the industry standard in 2013 for nuclear power plants of only 33%. This compares to coal, 33%, petroleum, 32%, and natural gas at 43%. This increase in efficiency allows for a decrease in fuel consumption with the same electrical output. The new design will have an overall increase in power output from an industry average of 1,150 megawatts to 1,700 megawatts, but yet will allow the the plant building volume to decrease by 20%. So as seen on the current PowerPoint, that is a pressurized water reactor as compared to the advanced pressurized water reactors shown here. So it takes up a volume of less than 20% or only 80% of the standard nuclear power plant currently in operation. This is an increase in 47% while also decreasing the physical volume it requires. This advance in thermal efficiency is in part to the utilization of neutron reflectors. Reflecting neutrons back into the core minimizes the neutron exposure rate in the reactor vessel, improving internal reliability and facilitating a more economical use of the core's fuel. The design of the US APWR incorporates a stress corrosion cracking resistant tube material for its steam generators, thus causing a reduction in maintenance costs over the life of the plant. The turbine blades themselves are planned to be 74 inches in diameter, promoting a more efficient use of the steam generator in the steam generator. Not only is the APWR an increase over the PWR in efficiency and overall design, but the newly built for US APWR has an estimated 10% increase of efficiency even over the APWR design itself. This Generation 3 style reactor is currently planned for use and construction as Unit 3 of the North Anna Nuclear Generation Station, as well as TXU's Comanche Park Nuclear Generation Station. Another form of nuclear power plant operation, construction, and design moving into the future is by way of modular reactor. These modular reactors are smaller in design and power output than their much larger output, more standard use of nuclear power plants. These modular reactor plants are referred to as small modular reactors, or SMRs. SMRs are capable of being operated in parallel with multiple other SMRs, as well as other sources of energy to supplement and or increase overall efficiency. SMRs are rated to be 300 megawatts or below, while fully operational reactors are currently rated 1150 megawatts or greater. At this time, no SMRs are built, fully designed, or licensed, but the Department of Energy, or DOE, believes that SMRs are to be a major method to combat energy, economic, and climate goals, if it is possible to be produced commercially in the next decade. One of the main leaders in the design and construction of the SMRs is the Babcock & Wilcox Company out of Charlotte, North Carolina. The Babcock design is considered to be a Generation 3 plus unit capable of being utilized with up to over 9 units of similar design. They have an operating life cycle of 4 years between refuelings. These much smaller units are capable of 155 megawatts and are capable of being shipped via rail. Now, while being considered rail shippable, these reactor cores will weigh in at an estimated 628 tons without being fueled, and an estimated 716 tons once fueled. Now, while nuclear power is sought after for being environmentally friendly, these Babcock & Wilcox designed small modular reactors take it to a different level of eco-friendly. They have a zero emission operation capable of reducing carbon dioxide emissions by an estimated 57 million metric tons per reactor over the course of a core life. The condenser is air-cooled and the steam generator is integral to the design of the core. Steam use will be a superheated steam system with an added 50 degrees of Fahrenheit, or corrections, 50 degrees Fahrenheit of superheat. So we just discussed 3 different options of nuclear power on the uprise. Now let's talk about on the downturn. One of the current decommissioning projects is the Crystal River 3 nuclear power plant. And one very, very valid reason to think that we as a country are sliding into a period of nuclear power becoming obsolete is the decommissioning of that said reactor. This Crystal River 3 is located at the Crystal River Nuclear Power Plant, located outside of Tampa, Florida. This nuclear power plant began operations in 1977 under the control of Duke Energy. This plant is one of 5 power generation stations held by Duke Energy at the Crystal River location, but the only nuclear power plant located on site. The remaining 4 are coal-powered. Crystal River Nuclear Power Plant, or CR3, was in the process of a maintenance shutdown in 2009 for work on its steam generators, as well as performing a power uprate. It was also in the process of filing paperwork for an extension of its operating license with the Nuclear Regulatory Committee until 2036. While performing maintenance on the steam generators, it was found to have excessive delamination, or the separation of concrete. This added a drastic cost to the project, which had to be remediated. The fixes were corrected and work commenced. Now, while performing operations to return the steam generators and the plant to service, more delamination was found, adding even more of a cost to the already extreme budget. On February 5, 2013, Duke Energy board members made the decision to retire the plant in preparation for decommissioning the plant in the future. The decommissioning of the plant will cost Duke Energy an estimated $1.18 billion at the 2013 dollar value. Taking into consideration the cost to repair the already older plant and future remediation costs, this cost to decommission the plant was more reasonable than the cost to restore and maintain operations. At the time of retiring the plant, CR3 had approximately 605 employees, operators and technicians alike. Of these 605 employees, only 230 remained working on site. 250 employees were reemployed elsewhere, either at a neighboring coal plant or elsewhere within Duke Energy, while 125 employees simply decided it was time to leave and received a severance package. This is not to say that all of the 125 employees are no longer working in the nuclear industry, just not working within the structure of Duke Energy. While the decommissioning of Crystal River 3 nuclear power plant will cost $1.18 billion, Duke will not suffer this astronomical cost alone. Nuclear Electric Insurance Limited has already given Duke Energy $305 million and are still scheduled to pay out another $530 million. This leaves Duke Energy with the responsibility of $345 million. This decommissioning will not be done anytime soon, however, with the scheduled decommissioning completion date of 2074. The Crystal River site will be left with 4 remaining power plants, once again all coal-powered, but will lose 2 of its remaining plants as they are to be retired by the year 2018. The other 2 plants are only in operation due to fixes and upgrades due to subsidies received. So in summary today, Jerry, Scott, and I presented information to you regarding new construction of nuclear power plants, to include Vogtle, VC Summer, and Watts Bar 2, and the decommissioning of several different reactors. We looked at the ideas available to help bring nuclear power plant back to life and how that may be done. The question now becomes, are we in a decline, or is nuclear power making a comeback? As it stands today, we have to agree that the decline of nuclear power continues. Thank you for watching.